Hey look, I've got a complete dual exhaust stack kit for my 1959 Rio Gold Comet truck. Everything is included. I've got the stacks, exhaust pieces, the Y-section, mounting brackets, clamps, bolts and nuts, and even the rain caps or flappers. How cool is that? There was one tiny complication though. I couldn't get this with a credit card, so I had to build it all from scratch.
I don't think so. No, 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 no. I don't think so. No, 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 no. It's never, ever, 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 ever gonna happen. I don't think so. No, 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 no. I don't think so.
I've been in and out here 101 times to get this piece together. Check it, mark it, cut it, measure it, back in to check it out, to measure and cut and mark and carry on. But I think I have now finally got it, and it's stack welded together and it's fitting. The vast majority of you guys voted for dual stacks, so I'm applying one of the democratic principles here, a free and fair election, and we are doing it. To be honest, I do have some misgivings about it. I'm not concerned with the fabrication side of it. I've got no issues there. But rather from a performance point of view, exhaust system design and its effect on engine performance. It has to do with the complex business of gas kinetics, exhaust gas velocity, scavenging effect, negative pressure waves, and other such like stuff that I know just enough about to be dangerous. A lot of you guys talked about back pressure. There's not going to be enough back pressure, or there's going to be too much back pressure, or you need a little bit of back pressure. Now this is where I'm going to be entering dangerous territory, and I'm going to let a cat amongst the pigeons and make the statement that there is no such thing as back pressure. Now hang on a minute, before you shake your head and disgusted, a stupid old idiot, and you click away. Hear me out. Back pressure, so that would be backwards pressure or reverse pressure, and then the opposite of that would then be forward pressure, front pressure, head pressure. Let's make a drawing. Here's my sketch, very simplified, of what's supposed to be a basic internal combustion engine. There's my piston inside the cylinder. I've got an inlet valve. I've got an exhaust valve and an exhaust, which is open to atmosphere. Kind of obvious, but something to keep in mind for later on. So now, if you will imagine with me, we've just finished the power stroke. The piston is at bottom dead center, and now my combustion chamber is full of exhaust gases. Now the clever guys reckon the pressure in here is around 6 atmospheres, depending on engine design. Whichever way, much higher than out in atmosphere. So now as the piston comes up in the exhaust stroke, the exhaust valve will open, and then because of that massive pressure difference, obviously the exhaust gases will flow out into atmosphere because of that little girl and all the EV fanboys with their range anxiety. Now if we were to stop the engine with the exhaust valve open, the pressure in here and the pressure out there will become the same. They will equalize. So the pressure in here will then also be 1 atmosphere, right? So now back pressure or backwards pressure would be a pressure in the opposing direction. I mean, that just makes sense. But there's a problem now, because the pressure here at the exhaust tip is atmospheric pressure. Now, how in the hell are you going to change that? Because that's what needs to happen if you want to change back pressure. There is a way to change this back pressure. Atmospheric pressure changes with altitude. The higher you go, the less it becomes. So if we want less back pressure, we can go and park our car on top of Mount Everest. Or if you want more pressure, you can go and drive along the coast at sea level. Hey, I just thought of another way to decrease back pressure now. Because at least in theory, the lower the back pressure, the quicker the gases will move out of the engine. That should make it a lot more efficient, right? Now, if I was to stick my car on one of those SpaceX rockets and take it into outer space, well, there's a vacuum out there. That'll make this pressure difference a lot higher, and the gases will go out a lot quicker. Thinking about it some more, that won't work now. There's no air out there for the inlet side, man. So, the only back pressure we have is that of the atmosphere around us. And we can't change that, man. This whole business of back pressure is an urban myth as far as I'm concerned. What we should be talking about is restrictions in the exhaust system affecting exhaust gas velocity. But these things are never simple, and now it becomes a way more complex. So the most efficient engine would obviously be the one that can get rid of those exhaust gases the quickest and do the most efficient exchange of inlet and exhaust gases, if I can put it like that. And now we've got to mention an important thing called scavenging that comes into play. And it's essentially the process of replacing that spent exhaust gas with a fresh air fuel mixture. That rush of exhaust gas leaving the cylinder helps to pull in a new batch of fresh air. So good exhaust system design improves that. But it's all affected by engine RPM, valve overlap, and stuff like negative pressure waves and so on. Way too complex for a mere mortal like me to understand. I do know that incomplete scavenging can lead to reduced power output, but let's not dive any deeper into this subject. It's not what this video is all about. I will add this though, with my low-revving engine here on the Rio truck and those oversized exhausts that I plan to build, hey, we might run into problems with exhaust gas velocity that's not adequate and strange pressure waves, blah, 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 all of that fancy, complicated stuff. But I'm just going to build it anyway and have fun. And then we will see what happens. If down the line I really feel that it is not performing the way I think it should, there are things I could do. I mean, I could block off the one stack. I could fit a smaller pipe inside the 4-inch stack. Yeah, things like that. But what the hell, let's just build it. I want a Y-section in this pipe like this. And a long time ago I saw a trick that a pipe fitter used. So I'm going to try that today. So first thing, I'd like to divide my pipe into 4 equal quarters. Now there are many different ways in which to do that. You could measure the circumference or even calculate it. Divide that by 4 and then measure along the circumference of the pipe. You could use one of these circle center finders, find a halfway mark there, draw a line across here perpendicular to that point. But I'm going to show you an easier way that does not require any measurements. Take a piece of paper and wrap it around the pipe like this. Now we do want these edges to line up, so we must just square it a little bit more until those edges line up like that. Now we got to find that point exactly where it overlaps, and we mark that so it would be right there. Yes. So this distance is then the circumference of our pipe. Now if we fold our paper until we just line up with that mark we just made, like this. That point will be the halfway mark, and then obviously if we fold it again, like this, that will be the quarter mark. Open it up, and we can just make marks here so that we can see them better, like this. And yes, piece of white paper with my dirty hands doesn't stay white very long in the shop. So now I can wrap it around my pipe again and transfer my marks. And yes, I've even got a helping hand in the form of an old hose clamp to help me keep things where they need to be. So if I've transferred all my marks, I just got to mark them all. I think this is the last one. Right, so now we can take our hose clamp off again. Thank you for your help. Just make these marks a little bit more pronounced. Okay, cool. So now I've got to mark every quarter of the circumference. A piece of angle bar is perfect for drawing a line that is parallel to the length of the pipe. Okay, now a little bit of maths. My pipe diameter is 76 millimeters. 3/4 of 76 is 57. I'm going to make a mark here at 57, which is right there. And I'm going to turn my pipe through 180 degrees. And on the other side I'm going to mark the quarter of my pipe diameter, in my case 76, which is 19 millimeters, a mark right there. Now I'm going to draw a line from that 57 millimeter mark, 3/4 inch of my pipe diameter, to the next quarter circumference point. I'm using a piece of straight cardboard, tape measure, or any other flexible business will work as well. Oops. That's the one. And I'm going to repeat it on this side as well. And then the same thing here on the opposite side. In my case to the 19 millimeter mark, which is 1/4 of the pipe diameter. So I've got now a cut line on this side, cut line on that side. So let's cut it. Right, so we've got the one done. Now let's be clever and use our same old piece of dirty paper to make ourselves a pattern for transferring this exact shape to our other piece of pipe. I'm just going to mark it like this. You can see it there. Alright, now we can take this off, cut it out, and we've got our shape. Let's cut this out. So you see, there are benefits to having dirty hands. Those dirty fingers work perfectly for making these marks. Right, I've got it wrapped around my other piece of pipe. I made sure it's lined up nicely. I've asked my hose clamp friend to give me a helping hand again. So now we can just mark it and then cut it. So we'll just follow our pattern. Righty-o, so take off my paper pattern. Thank you for your help, Mr. Hose Clamp. Let's get cutting. So I'm just looking at this shape now, and I'm thinking something's not right here.
Because this line that I marked here, while it's straight in this orientation, when the pipe sits like this, which is about where it needs to end up, that line should be straight. So actually, something needs to be removed right there. And that would go for the other side as well. Yes, and if we put the two together, we can see that is exactly what needs to happen. A little bit of material needs to be removed. Yeah. Still, it's pretty close. I'm wondering now, maybe I remembered something wrong from when I watched that pipe fitter so long ago. But we'll make this work. Yes, a little bit of messing around with the grinder. Now I've got a nice fit. Turn it over. Already given it two tacks, the side light ones, just to keep the whole thing together. And now the final piece of my little puzzle fits right there. I can weld that on. And I've got myself a Y-joint or a splitter or whatever you want to call it. Now I have to go from a 3-inch pipe to a 4-inch pipe. So I could just weld in a disc and cut a 3-inch hole. You'll have a step. But I think a cone-shaped tapered transition, something like this, will look much better. Now how can we do that? So here's my plan. I would like to cut out 8 pie cuts, something like this, all the way around. And then I can squeeze those pieces in to hopefully then meet up with the diameter of the 3-inch pipe that's going to sit there. So the first thing I'm going to do now to get the accurate and equal layout is I've cut myself a piece of stiff paper so it meets up like that. It's exactly the circumference of my 4-inch pipe. So this piece of paper, this length here, is then in exactly the circumference of my pipe. I don't even know what that dimension is, but it doesn't really matter. So what I'm going to do now is I'm going to fold it in half, fold it into quarters, and then fold it into eighths. Thus, you can open it up, and now I can make a mark on each of those fold lines. So now I've essentially divided it into 8 equal parts. I'm sure you know what's going to happen next. So I've stuck on some tape just so that my old eyes can see my mark better. But there's another reason. The tape will also show me this edge here, how deep I want to make my pie cuts. I've used 2 pieces of 25mm 1-inch tape. 1 piece of 2-inch or 50mm tape would also work, but yeah, I haven't got any at the moment. So now with that in place, I can now put my piece of paper in place, like this. I'm just going to stick it on like that. And now I can transfer my marks. And now I've got 8 equally marked sections or marks on my pipe. A piece of angle bar is going to help me get my marks all parallel, like this. So next I've done the same thing on my 3-inch pipe. So this piece of paper that I've got right here gives me the circumference of my 3-inch pipe. So if I now place these 2 pieces of paper next to each other like this and line up this edge, that difference in length, that distance right there, that would also be the difference in circumference between the 2 pipes, right? So I measure this difference at around, let's call it 84 millimeters. I need to divide that by 8. If you work in inches, you must be clever. It's much easier to divide 84 by 8 than, what would the inches be? 3 and small little bits. 3 and about a quarter. To divide that by 8 is complicated, man. So 84 divide 8 equals 10.5 millimeters. That's easy enough. You don't even need a calculator for that. So for all practical purposes, I'm going to call it 10 millimeters. So now if my thinking is right, 10 millimeters will be the width of my pie cut right on this edge. So obviously half on either side, which would be 5 millimeters. So then I connect to that point. I draw my other line right there. So this is the size of my pie cut. I keep saying pipe cut when I need to say pie cut, man. Yeah, so I'm just going to mark all of them, and then we can find out if this is going to work out. Okie dokie, I've got them all laid out. Now this distance determines how gradual your taper or your cone is. In my case it's 50 mil, 2 inches. If you want a more gradual cone, you need to increase that. But I think this is cool for me. So let's get cutting. And last one. Now I can remove my tape. Right, so now I'm going to use this big old shifting spanner to bend all these tabs in a little bit. I think some of you guys also call it a crescent wrench, if I'm not wrong. Here in South Africa, we sometimes jokingly refer to it as a free state micrometer. If you know, you know. So a little bit at a time, so that we want to try and get them all to match up equally. So I'm just going to keep at this until I get those points to meet nicely. Close, maybe a little bit of fine tuning still. But we are getting there. It might take a little bit of fiddling, obviously. Nothing wrong with a little bit of persuasion to fine-tune the state of affairs. Right, the moment of truth. Let's test it. Now, that's not half bad. I could probably fine-tune it a little bit more, but it's quite close. You might have to cut your slots a little bit more, but that's okay. Now obviously it will not be a perfect match. You can see the radiuses that we have here from the bigger pipe. It won't be an exact match to my smaller pipe. Now if you want to be anal about this, you can use a dolly and a hammer and change them a little bit by hammering. Don't think I'm going to bother too much. Now another thing, obviously if you transition from quite a small size to a bigger size, say from 2 inch to 4 inch for instance, this business will be more pronounced. Then it might be better to make more cuts, say 12, and you could even, this radius change will also be worser. Is there even such a word? I just made it up. But yeah, you could just play with a hammer and a dolly a little bit if you want. But this is pretty close. I'm just going to fiddle with it a little bit more, and then we can weld it all together. Like that. Yeah, I didn't want to flash your poor eyes with more welding footage. I'm sure you've seen enough of that. And then because I'm not that good at laying dimes, I cleaned it up a little bit with the grinder and made it look pretty. Yeah, not that good at laying dimes. damn good at spending dimes. And then I also welded on this, shall we call it an expanded section that I made by welding on 2 halves of 3-inch pipe that I opened up a little bit. So now my 3-inch pipe can go in there like that. Nice tight fit. And we can stick a clamp right on there to hold it nicely in place. There we go. Yeah, and since I probably would not be able to find a 3-inch exhaust clamp in my local little town, I thought it would be just less painful to make my own, which I did from a piece of 20 by 3 flat bar. That would be around 3/4 by 1/8 for my American friends. And this is good, man. I think it's better than a boughten one. I found these elbows at my local steel and pipe supplier. Seamless, JIS, 2.5-inch nominal bore. And the OD of them is an exact match to my 3-inch 75mm pipe that I'm going to use for my exhaust system.
Much later.
Last piece of the puzzle. I've got this bottom pipe. It comes out from the splitter, is now lined up with my stack. So all I've got to do is measure where to cut it off, and then I can fit this elbow. I can drop this down because it's sitting in the clamps, line it all up and tack weld it together. Okay, so I've got the whole system fitted up, but now most of my pieces are still only half welded and tacked. So instead of crawling around under there and having those little hot balls of steel dropping on me and falling into strange places and burning the hell out of you, I think I'm just going to take the whole thing apart so I can weld it up on the bench. Much less wear and tear on the old bones, I think. All the pieces are out, and I can now go and finish the welding on my bench. Yeah, Wayne. The things I get sucked into. Now what? What's the story?
The things I get sucked into.
Well, you're a sucker for being sucked in. So what, is this a tractor from some neighbor or someone?
Yeah,
what's-
next door neighbor.
And these guys obviously don't give a damn
Ish.
about maintenance or anything like that.
No.
They just drive it into the ground.
The bolts that weren't missing broke off.
So all of this, what's wrong with it?
This whole, the arm, what do you call this? In the
3-point.
The 3-point, yeah.
All broken and busted and tied together with bits of wire.
I mean, there's nothing.
Oh well, let me give you a hand.
Yeah.
What do you want me to do?
Just pull the jack, I think will be good enough.
Oh, you lose.
Yeah.
Can we go?
Yeah. Yeah.
Right.
Nice.
Now you can evaluate.
Okay.
Let me come a little bit more.
All right. Okay.
It's gonna fall.
It's all right. It can fall.
What a contraption, eh?
2 hours later.
Well, hey, you're in front of my view. Another forest engineering fix. Lots of welding and new bolts and studs and what have you.
Well done, sir.
Yeah,
Thank you very much.
you owe me a beer.
Definitely. Maybe even 2.
I cut one of those 90-degree weld-on elbows in half to get this 45-degree bend. But I needed a little extra bend in this area here. And now, of course, I don't have a pipe bender that can handle 3-inch tubing. So what I did is to make these 3 little pie cuts 3/4 of the way through the pipe. I could bend it a little bit as I need it. And then I will just weld this back together again. Yeah, forest engineering style. Well now, I'm not calling myself a TIG welder yet, but I am getting better at this business. I found this old stainless steel fireplace flue at my favorite place of shopping, which is the junkyard, of course. And I'm thinking to see if I can turn this into heat shields for my exhaust stacks. The diameter of this thing is about 7 inches. So that'll work okay on around my 4-inch exhaust stack. It's more than long enough. And I like the fact that it's got some wear and tear and history and patina on it. I think that will suit the picture very well. So my idea now is to cut this thing into 2 halves, and then we can take it from there. Right, so I've got my 2 halves. Nice and sooty inside. That's still longer than it needs to be. But I'm only going to decide on my final length once I can fit them to the stack. So we're going to leave them like that for now. Look here, I paid 100 South African rands for this piece. That's in the region of about $6 US. Yeah, last time I checked, the exchange rate was in the region of $18 or 18 rands for $1 US. So I made this rolled piece of 30 by 3 flat bar to be a nice fit in there like that. Still a little bit too long, so I can cut it to length. And then I can also drill holes in the flat bar for bolting my heat shield to the flat bar. So I've made 4 of these clamps, as well as those half round pieces there. So the idea now is that they will clamp onto the stack and form part of a bracket that will be able to hold the heat shield. So my plan is to maybe put in a bit of flat bar here and weld this half round onto my clamp, and then the heat shield can attach to this, and then the heat shield can still be removable if need be. Something like that. Turned out to be quite an interesting bracket, eh? And 3 more for a total of 4 brackets, 2 on each side. I've been getting in some good TIG welding practice here. Right, so let's go and see how this is going to work. So my first fancy bracket will sit down here somewhere, and it can be clamped on in the right spot. Then another one. And now my heat shield goes on like that. And then this can just be drilled and tapped to fasten it. Yes, I think that's going to work out very well. Also made me 2 rain caps or flappers, call them what you like. This here is a fence post end cap that I found at my steel supply store. The rest is just bits of flat bar. I made it so that it can clamp on. I added this counterweight there. So you can always fine tune this by adding more weight or taking some off. Yeah, we'll see how it works out. Let me show you how this bracket works that holds the stack to the side of the cab. And then you can tell me whether it's a cock idea or not. There's a word you might not know. It's a South African slang word for crappy or shit. And yeah, it's a relatively crude word. It's not a word you would use when you're in fancy conversation, but then we are just normal folk, right? So let me just take this 4-inch pipe out of here so you can see the bracket better. So this flat bar part bolts onto the side of the cab, and then this clamp here that clamps onto the 4-inch stack is being held on there with a bolt. Let me just take that out. And then this can now come off like that. Let me take you closer so you can see what's going on here. So what I've got here is essentially a rubber bushing. Now I don't know how they do it on the big rigs, but my reasoning behind that was I figured it would be a good thing to allow for a little bit of movement. The cab is on rubber mountings, so the cab can move a little bit relative to the frame, and of course the engine is on rubber mountings, so the engine can move a little bit relative to the frame, and so on and so forth. And I just figured a little bit of allowance for movement here would be a good thing. The fun part was that I could make my whole bushing right here in the shop from scratch using forest engineering techniques and bits and pieces I could find here. So this piece of pipe, nice fit for my bolt. And then this piece of pipe is a nice tight fit inside this piece of the rubber fuel hose. I got to really squeeze it hard, but you can see it will fit in there. And then this piece of rubber fuel hose is a nice tight fit into that piece of rubber fuel hose. Let me see if I can push it in there like this. And that goes in there. So once I had this made up, I couldn't quite find a piece of pipe that was an exact fit, so I took a little piece of length of this pipe, I think it was 1.25 inches, 32 mm, split it, squeezed it closed a little bit until I could get a nice tight fit for my newly made bushing, and then welded it. My little piece of steel pipe is just a tiny little bit shorter than the length of the rubber hose. So when my bracket goes on, which is a good tight fit like that, when I tighten the bolt, It'll squeeze the rubber a little bit until it gets to that steel insert, and then it all becomes nice and tight, but it will still allow a little bit of movement. Yeah, so maybe it wasn't worth the trouble, but it's done now. It will hold the stack in place. It will work. So I've got nothing to lose. So whilst I was at it, I used the same method to make these two exhaust hangers. So this end connects to the frame. That end bolts to a tab that's welded to the exhaust pipe. This piece here I just cut from a piece of, what was a 2-inch 50mm box section to get that piece. Now you might think that this is not going to give enough movement, but when we had the engine running, I revved that engine and checked engine movement, and there was actually very little. Those engine mountings are quite stiff. So I think this is going to be fine. We will find out. Okay, lekker man. All my pieces are now welded together and they are ready to be installed. But I think I'm just going to give them some paint quickly. Dry coat. Now what's that all about? I bet many of you have never seen such a thing before. So here in South Africa, braai is the word for barbecue. And let me just quickly read here on the tin for you. A specially formulated self-priming quick drying paint for use on mild steel surfaces that are exposed to high temperatures. I've actually used this stuff with great results in the past on mild steel exhausts. Well, obviously it doesn't last on exhaust manifolds or headers. I mean, pretty much nothing lasts there except ceramic coatings and complicated stuff like that. So I'm going to use this again. It works for me. All my bits and pieces are painted and I can proceed with final installation and scratching my fresh new paint. Well, I'll tell you, I'll be lying to you if I tell you I didn't struggle to get my pieces fitted here. Yeah, I suspect it was because of a little bit of distortion when I welded them together on the bench. You know, I actually thought about it at the time. And then I said to myself, we'll worry about it later. Well, now is later. Anyway, I got it done. And I'm sure you would like to crawl in here with me to see what it looks like. So my first section goes here from the exhaust manifold on the right hand side to a point here in the middle of the frame, right underneath this cross member. Still plenty of ground clearance. It sits higher than the front axle. Yeah, it does look very close to the sump right there, but it's just a camera angle. There's massive amounts of space. So right here I attached it to the gearbox, or the transmission as some of you guys like to call it. I did that just to make sure that there's no additional stress on my exhaust manifold. So this section of the pipe is then clamped to the exhaust manifold and attached to the gearbox right there. And look right there, some of my fresh paint is already scratched off as I struggle to get all this fitted and banged it with a rubber hammer and whatnot. But we don't care, it's just an exhaust on an old truck, right? Okay, and then from that center point we move into the Y section so that we can have equal lengths for each stack. So this is going to the one stack, this is going to the other stack. Now in the perfect world right there I need a flex joint. Now I couldn't find a 3-inch flex joint here in my area, and I wanted to get this in place and done. So we'll see how it's going to work out. There might be a little bit of movement on that joint right there. Like I said earlier, this engine doesn't move much. The mountings are very stiff. The rest of the exhaust leading backwards is mounted on rubber. So we'll see how it works out. If need be, I can always install a flex joint right there later on. Now, and then this section that goes from the Y piece into the exhaust stack, same thing on both sides. There you can see my forest engineered exhaust hanger, and oh, that wire up there, yeah, that needs to go to the fuel tank sender unit. In the non-existent fuel tanks, I've still got to bolt those. And yeah, look at this. Have you ever seen such a crooked finger in your life? Look at it. I can't make it straight. It still works kind of fine though. Well, I can't really bend it that much. I cut it quite badly with a grinder quite a long time ago. Yeah, and ever since then it never quite came right and it's been crooked. Yeah, but still good enough. So from the 90-degree turn we go into the exhaust stack, and then we go up and up and up. And I even had to raise that workshop light up there to make room for it. Yeah, I scratched up my paint very nicely to get this mounting bracket for the heat shield in place. So now we can fit those. Let's see, this goes on like that. Oh, that fits nicely. I can get my little screws into place. One here on this side. And I got another one on that side. And then we'll do the same in the bottom, and then we can have a look and stand back to see what it looks like. Yep, that's not going anywhere. So when Wayne saw this thing, he wanted to whip out the polisher. And I said, hold your horses, my brother. But OG likes the rust. Of course, OG in this case is old geezer, eh? So, I don't know. I might drill it full of holes. We'll think about it. And just to complete the picture here, the plan is still to paint the cab in yellow. Just a rough paint job. Don't expect show quality. Let me try that again. Don't expect show quality scenario. So, which team are you batting for? The shiny Barefoot Mechanics team or the Patina OGs team? Let me know what you think. Final piece of the puzzle. So both my flappy things are fitted. Down here everything has been checked out and tightened, and all is looking good. So I'm finally ready to start the truck so we can hear what this business sounds like. I can't wait. Well, there's no mufflers in there, so she's going to be loud. Are you ready for some noise? Let's give it a shot. I'm giving it a little bit of choke. Holy cow, that's loud. Well, I guess the building does amplify the sound a bit. I don't know, I might have to build some mufflers to insert. But I think before I do that, let's first get her out of the shed and take her for a drive and see what she sounds like when she's in open atmosphere. Still got to do a few things before we can do that, but we'll get there. Are those stacks too long? I guess they probably are. Am I gonna cut them shorter? No, why should I? At least not yet anyway. Will I be able to get the truck out of the shop? No, they stand way too tall. But I've made them removable. So we can just take them off when you want to take the truck out and then stick them back on. So I guess my dual stack exhaust is pretty much done. Like I said, there might still be a few changes here. It will just be cosmetic, whether we polish it or not, make some holes in it and all of that. So if you're still here, thanks so much for hanging out with me. I enjoyed your company. I'll see you in the next video. Until then, have a lucky one, my brothers and sisters.
Whatever makes you happy, it just depends on you. So think of